Disclaimers. I do not have any actual beef with anyone mentioned in the video. Please do not harass or send hate to anyone mentioned. This video, and the hybrid or hybrids, are just purely made for entertainment purposes. With all that out of the way, let's get to the video. Hello guys, this is Cooldinos and welcome back to another Great Hybrid War video. Gosh, I haven't made one of these in a minute. It's great to be back in the hybrid making business. Ever since the past year, I've been in almost every major hybrid competition known on YouTube. From Goji Center's Great Hybrid War, the Sky Hybrid Wars hosted by Zion Reborn 2, which is still ongoing as I'm recording this, as well as Valis Dreadmir's Hybrid Tournament. I would have participated in Goji Guy's Aquatic Hybrid War with Vex, but I was busy back when it was ongoing. I did compete in some other smaller competitions, which also had some pretty fascinating creations come forth. However, a new challenge arises. A little while ago, during my, hopefully, last spring semester of university, I was notified that another fellow hybrid creator, Baku, the same creator that made the Tough as Nails jellyfish hybrid named Hydractus during Goji Guy's Aquatic Hybrid War, the champion of the Bay of Bengal, and the Orc Dog, the winner of Valis Dreadmir's Hybrid Tournament, is hosting his own Hybrid Battle Royale, but with a unique twist. It works on a tiny scale. No, I'm not kidding. This challenge will involve only tiny animals, as ecosystems all over the world throughout Earth's history don't just have giant animals like the charismatic megafauna we know of, but even the tiny, small creatures such as small insects, reptiles, birds, amphibians, and mammals, as well as crustaceans, fish, pterosaurs if you count the Mesozoic, and more. Before I continue, I should explain the rules and details of this hybrid battle royale, as stated in Baku's video. Many of the general rules, such as using only real animals, both extant and extinct, not using fictional creatures, unicellular organisms being forbidden, no use of AI, etc., still applies. However, there are a few details I need to explain. The max weight limit for any submission in this context is 100 grams, which is roughly the weight of a bar of soap, for reference. Said creations cannot exceed this limit at adulthood, otherwise they'll be disqualified. Additionally, even though we can use real organisms for the genome, we only have to use valid taxa that have enough fossil material to understand the animal or well-documented studies of said animal. This especially applies to extinct organisms. Fragmentary species are not allowed. Another rule is that only one singular organism should be sent per submission. Once the organisms enter their respective biodomes, those being sectors A, B, C, and D, which I'll explain later in detail, anything that happens inside is fair game. Not to mention said hybrids will be put up against their neighboring hybrid competitors within the same biodomes. With all that out of the way, let's get right to the genetic contributors, using an all-reptilian genome to our advantage, a total of 7 contributors. Does my tiny pioneer have what it takes? We'll see soon enough. Before we go on to reveal the full genome, make sure to like the video and subscribe to my channel, and make sure to click on that notification bell to not miss out on more content. It really helps my small channel, and I hope to reach my goal of 1,000 subscribers by the end of this year. I also wish to thank you so much for your support of my channel, both old and new viewers. Subscribing is also free. With all that aside, let's get right to it. The first 3 genetic contributors are all of the Anolis genus. Let's begin with the first one, the green anole, or Anolis carolinensis, which will serve as the primary base for the hybrid, with some additional benefits that this species brings. Green anoles are highly adaptable and thrive not just in natural ecosystems all throughout the southeast coast, but also thrive exceptionally well in suburban and highly developed areas. These anoles serve as the primary basis for their overall intelligence, as some anole species have been documented to have intelligence on par with more intelligent birds and mammals. More on that in a moment. One last thing that this anole provides is their ability to change the color of their scales from green to brown, and vice versa. or from brown to green. The second species out of the 3 anoles being utilized is the brown anole, or Anolis sagre. By utilizing another species in the Anolis genus, we are doubling down on the adaptive capabilities of this species, and only a partial color influence on the dewlap, as well as a faster maturity rate from roughly a year to reach adulthood to maybe a couple of months. This may not change too drastically, but at least it would give my reptile a bit of a slightly faster maturity rate. Additionally, brown anoles contribute in boosting the intelligence, being able to solve novel tasks and being able to retain and reapply these experiences and solutions, based on documented studies on anole intelligence. Lastly, they'll contribute to an overall greater immunity to toxins and chemicals within their environment, such as heavy metals. The third and final anole we will be using is the largest species in the Anolis genus, the Cuban night anole, or Anolis equestris. This critter is going to be used for a partial size enhancement, which will allow our hybrid to weigh from less than 10 grams all the way up to a possible weight range of approximately 20 to 30 grams. Additionally, in order to support this new weight, we'll incorporate the musculature of the limbs into the hybrid, as well as some modifications in their skull morphology to become more robust and muscular to support a stronger bite for its size. A few additional pieces of information pertaining to the anoles. While they're primarily insectivorous, they do have the capacity to eat plant matter, as a decent amount of species within the Anolis genus have been documented to consume food items such as fruits, seeds, nectar, and pollen. Some of these do overlap between species. However, we'll be enhancing and expanding upon this in a moment. Anoles also have rather great depth perception and superior eyesight, allowing them to navigate their environment with ease. The following contributors from here on out are lizards from different families and are different species, and are either not directly related to or unrelated to the anoles used in the genome. The next contributor in this lizard's genome is the green iguana, or iguana. This is actually a decently congruent addition, considering both anoles and iguanas are in the infraorder Iguania. However, at the same time, this addition may seem counterintuitive, as this creature can weigh an average well above the 100-gram weight limit. But I will not be using this for any additional size boost, but rather slight dietary and muscle adjustments. The green iguana will not only contribute to influencing the herbivorous side of these anole hybrids, while still maintaining the omnivorous traits of the anoles with some proper genetic adjustments, but also expands the range of plant matter they can eat, which includes some small, fresh tender grasses, leaves, and flower petals, as well as only slightly modifying and enhancing their jaw musculature without drastically changing their skull morphology. The fifth contributor in the genome will be a lizard that some of you are familiar with, if you recall Goji Center's first great hybrid war, the whiptail lizard. I will specifically be using the New Mexico whiptail. Now, you may be wondering if I'll be making my creature an all-female species like the whiptail is. And honestly, I would not blame you. I originally was going to have this hybrid of mine as an all-female species and only reproduce asexually, as some whiptail lizards are known for this trait. However, this will be one of the few exceptions where I may use some precise gene editing, thanks to a friend of mine who suggested this. But let me explain. Some species of reptile, while not having obligate parthenogenesis like whiptails for example, can undergo what's called a virgin birth phenomenon, where females of the species could lay fertile eggs and result in all-female offspring, even when the individual has never encountered another male in their entire life. Because of the presence of an iguanid, we may just be able to do that. While both males and females will still be present, with sexual reproduction being the main method to have viable offspring, females of the hybrid species can undergo parthenogenesis, which will give rise to all-female offspring, which, while they will be clones of the mother, will be genetically diverse as well, due to the way the genetics of the whiptails work. As whiptail lizards, particularly the all-female species within the genus, can reshuffle their genes on their own while, producing eggs. The sixth contributor in the genome is the 5-lined skink. Now, I will explain why this small lizard is in the genome. For context, unlike most lizards where they lay their eggs all at once, female anoles typically can have multiple eggs throughout a long breeding season. However, they usually carry one, occasionally sometimes 2 eggs at a time, as opposed to multiples at a given instance. Now, anoles do not exactly exhibit parental care. However, some species of reptiles do. By utilizing the 5-lined skink, we will influence the behavior of the anole hybrid to, at the very least, keep watch and protect the general nesting site every so often until hatchlings emerge. We finally reached the last animal in the genome, but certainly not the least. Introducing the major skink, an Australian reptile. Now, this lizard actually contributes to one unique trait, which I will be using as a backup plan should my lizard come across any venomous organisms: the immune system. Now, these skinks have a robust immune system against highly venomous snakes with powerful neurotoxins, thanks to mutations on their nicotinic acetylcholine receptors, or NACHR. This trait actually independently evolved, perhaps in multiple lineages, over 25 different times. There are similarities seen in the honey badger's immune system as well. However, unlike the badger, where they have to sleep in order for the immune system to kick in and fight against the venoms, this reptile doesn't need to sleep, as said immune system mutations work as a form of molecular armor. This form of immunity would be useful against creatures that utilize neurotoxic venom. Combining all of these contributors and what they provide, we create a lizard capable of not only being highly adaptable, but also survivable, with these 7 all-lizard reptilians. I present to you my newest creation, the Anolis adaptatus, or the adaptive anole. This creature's stats are provided on the screen for both male and female specimens, with the congruency test of all 7 contributors being squamate reptiles and in the suborder Lacertilia, as well as 4 out of 7 of these contributors being in the infraorder Iguania. You can pause here if you wish to read everything on screen. Now I shall explain some of its anatomical adaptations and behaviors thanks to the contributors it has, as that will be another thing I will discuss about the adaptive anole. Let's begin with offensive capabilities. For the offensive, the anole can utilize its rather strong jaws as its primary method of attack. With the combined musculature modifications of the Cuban night anole and the green iguana, we get an anole that could possibly, theoretically, break the exoskeletons of insects, at least some of them, in its size range, as well as break skin on a handful of animals. Both the bites of green iguana and Cuban night anoles break skin, and with their combined traits, we get an anole that does have a relatively strong bite force, of course, relative to its rather small size. For defensive capabilities, it can do a few things. The first being that it can easily run away if it feels threatened, which may or may not be the first thing it does. However, in the chance that something does catch it, like many lizards, they can, quite literally, drop their tail to serve as a distraction for predators. One last defensive capability is the ability for both males and females to puff up their dewlaps and bob their heads up and down while doing so, which can be used either for signaling amongst other organisms as a courtship display to attract mates, which is the least likely in this competition, or ward off rivals in the case of males, while females use their dewlap more for aggression towards other females or for mating, although they use it less frequently for males. For other species, it could be a form of intimidation. An additional passive defense is its immune system, which I explained a bit ago when covering the major skink and the brown anole contributors, but to briefly recap, they have a strong immune system to where they're able to tolerate heavy amounts of toxins and chemicals in their environment. An example would be heavy metals, as well as being able to be highly resistant to or immune to neurotoxic venoms. Another thing I need to mention is their environmental adaptations. While anoles are typically arboreal, some are trunk-ground ecomorphs. Thanks to the combined adaptations of the green anole as well as the brown anole, Anolis adaptatus can exploit both arboreal and ground settings, as well as a variety of food sources, thanks to the combination of physical traits from its anole contributors, which includes its toe pads and millions of tiny hair-like structures, called setae, which are used to adhere to surfaces in order to climb, and great depth perception, which allows the anole to navigate complex environments, as well as their decent tolerance to a wide variety of temperature ranges thanks to the base itself, the green anole. Additionally, it is able to change colors of its scales from green to brown and brown to green thanks to the green anole as well, which is primarily used for a couple of reasons, such as camouflage, thermoregulation or temperature regulation, and managing stress, which is controlled by hormonal changes. Earlier in the video, remember how I mentioned about there being 4 different subsectors in this competition? Well, I'm going to briefly explain those, but check out Baku's video for more detailed information about the competition. I'll briefly go over these different biodome options. Sector A mimics a dense tropical rainforest habitat, moist and humid with a variety of trees and plant cover. There is a built-in stream, as well as a log placed there by intention as the focal point or focal points of this biodome. Sector B mimics a Mediterranean grassland, with a variety of grasses and flowers, and at the center, an olive tree is intentionally planted there as the focal point of this ecosystem. Sector C imitates a desert, or more arid shrubland environment, as characterized by low humidity and high temperatures, and coarse sandy terrain. There is sparse vegetation, but it is highly specialized as cacti and succulents are present, which provide limited shade and microhabitats. Lastly, of these subsectors, Sector D is engineered to imitate a coastal environment, with various intertidal rock pools and fluctuating water levels and salinity gradients. Much like a marine ecosystem, this biodome includes rocky outcrops, a shallow pool, and even a mangrove cluster. The primary sector in the center of these subsectors is Sector X, which is the convergence point that will be made available once a certain number of contestants remain in the Battle Royale, as well as a certain indeterminate amount of time passes. Said hybrids must migrate to this convergence zone within a certain time frame upon the gate's opening. Otherwise, they'll be disqualified. Now, in the context of this anole hybrid I have created, both sectors C and D are non-viable options for my creature to live in, as it is not a desert-adapted reptile and not quite adapted for coastal life. As of sectors A and B, they are more likely. While I have considered Sector A to be the best viable locale for my anole hybrid, I would have sent it there if it wasn't for the fact that there's a high percentage of submissions going to Sector A. However, Sector B is still viable, as not only would it contain a lot of ground cover to blend into the environment, it would also have, probably, a decent amount of shrubbery and sparse trees to hide in, as well as the aforementioned olive tree. Another reason would be the occurrence of morning dew forming on vegetation, which would allow my hybrid to have a source of water to drink from in the mornings. That, and because there's less submissions going over there than Sector A. Because of these factors, I've decided I'll be sending my anole over to Sector B. As head scientist of the Harrison Foundation's Biosciences and Bioengineering Division, we bring forth a creature that will, hopefully, be able to become a viable pioneer to this competition, as well as a worthy combatant. However, you may have noticed that it has a relatively lighter weight compared to the other submissions that weigh significantly larger than this anole. And on top of that, why this species doesn't have any extra armor or other abilities. I actually will explain this reasoning. For this creation, I didn't wish to use a creature that was to be the heaviest it could be for the competition, unlike some of my entries from previous hybrid wars. While the species can reach somewhere within the 20 to 30 gram range on average, I wished to spec more on survivability and adaptability as opposed to pure aggression or combativeness. And while it does have the capacity to damage certain creatures, I also didn't apply certain traits such as armor or venom delivery, as it would make my creature either a bit slower, less agile, or would be too metabolically demanding. I wish to take a more unique approach to this challenge as opposed to using a hybrid that reaches the maximum weight. Would it put my lizard at a great disadvantage toward other creatures in a one-on-one confrontation? Most certainly, yes. Especially if the other hybrid's either much heavier, faster, armored, flying, wields chemotoxic venom, or any other offensive or other unique strategies. However, this lizard can manage by utilizing other survival strategies and methods in order to survive. Now, which of these specimens will I be sending over? Well, I have considered both options, and while a male would be more advantageous in one-on-one confrontations, it would be more vulnerable to wounding and drastic energy requirements for their territorial, energy-intensive, aggressive activities, which could be detrimental in the long term, and thus once killed, it'll be game over. However, with a female specimen, considering females of the hybrid could not only potentially undergo facultative parthenogenesis, again through precise gene editing to a degree, but also undergo sexual reproduction with a male and continue reproducing offspring even after initial matings, it can still keep the ball rolling. Assuming the one specimen sent to the biodome can successfully lay eggs and hatch, and once said hatchlings can successfully reach adulthood, they could very well continue the game even if one individual is predated. On top of this, females aren't nearly as aggressive as males are, on top of often not dispersing as far as males would. Now, before I continue, I do want to cover some of the potential weaknesses or flaws of this creature. I have already explained at least two of these a little bit ago, but there is one I need to mention. The possibility that said facultative parthenogenesis of the hybrid, even though there's an iguanid in the genome, combined with the New Mexico whiptail contributor in place, may not work as I described, even though some reptiles can undergo facultative parthenogenesis. However, in this case, said parthenogenesis in this context, at least facultative parthenogenesis, would come specifically from precise gene editing from the New Mexico whiptail. This issue may or may not be solved due to the ability for female anoles to still be able to produce and lay fertile eggs even months after initial encounters with males. In short, the strategy I'll be going with is not to be the biggest, strongest, the most heavily armored, or extremely venomous or poisonous, but rather to be not only something that can survive, but also a species that can adapt to varying environmental pressures in terrestrial ecosystems, and to hopefully establish a healthy, thriving population within the biodome that they'll be sent to. Well, I believe that is all. I apologize for the long video. I want it to be as descriptive and explanatory as possible to leave little to no doubts about this creature. Also, I was fortunate to make this thing right when I was taking a herpetology course this spring semester, which in part really helped me out when making this tiny critter. I learned so much from that class. Additionally, I wish to give my thanks to Baku for giving me, and everyone participating, this opportunity to take part in this unique challenge. Thank you all so much for watching. Make sure to like and subscribe and hit the notification bell to not miss out on any more content. I wish the best of luck to everyone participating. See you all in the next one. Bye everyone.